Hello all. Let's get started with MBD process steps. So you can see in this diagram, this is the V cycle of software development life cycle process flow for model-based design that contains V and V, like verification and validation together inside the same process. Okay, we can read this diagram from top left to right left. We can go from here to here. Okay, so first step is requirement analysis. There we can have some requirement of customer that we are documenting. Then we are making that simulation like algorithm design in that way. Then architecture design, where the architect will come and they can work what they want, like at top level of architecture and all these things. Then simulating model design will come in a picture. Then implementation, model testing, integration testing, system design and acceptance testing. That all process how it will work we can see one by one. Okay, so first step is derive the system requirement. So what inside it? Based on customer goals and research system engineering, derive the system requirement specification. The requirement specifications cover physical and functional aspects. Regulation and guidelines are also taken into accounts. The if we are regulation and guidelines means if in automotive we are following ISO 26262 guidelines and all these things. Okay, so the system engineering creates executable system specification models which can be reused and enhanced during the further development process phases. This process reduces the knowledge loss that could occur during the handover and the requirement to the engineers responsible for the subsequent stages and saves their efforts up to the same extent. Okay, this is all about the derive the system requirement. So next is define what is the system. So once the system requirement have been fully defined, the next step is to create a executive system definition. As per the size of complexity of the system, the respective system is modularized into the different systems, components, which helps to effectively carry out the overall development cycle by enabling concurrent development and the design reuse. In small iterations, the system definition is continuously refined as per the system specification. The uncomplishment layout of interface between the components is drawn. The components are to be modeled, simulated, and verified individually, and later they will be again integrated for verification of the complete system. This is all about the define the system. So next is define the system architecture. During the third step, in this third step, what is define the system architecture? The system architecture is described by elaborating the system component in detail. These components are broken into hierarchical model component or subsystem conquering their functional and physical behavior of enhanced maintainability. These steps is also called high-level design. For architecture design, different properties are further derived for each subsystem like inputs, outputs, internal signals, states, variables, and parameters like constant and all these things. So next is design the simulating model behavior. That's the important thing. So after all the components previously mentioned, we are well defined and their simulating model behavior is described for their physical and functional properties using a different mathematical models. This step is known as low level design. Two types of model are developed during the phase. One is the plant model, another one is a controller model. So what is the plant model, what is the controller model? So let's get started. The plant model minimize the non-software behavior of the real world, such as a physical, thermal, numerication, hybrid, electric, mechanical, or environmental relationships with the system. The enable early validation of the control model logic in a closed loop simulation with near real world iterations. Matlab offers various toolbox based on the applications to support physical and environmental plant modeling. Controller model. The controller models are designed for development on the hardware. The model algorithm can be explained with logical, algebraic, and linear, nonlinear differential or difference equations. These equations are further implemented using a block diagrams in a Simulink. The parameters values are also defined in a model. Model developers can share and reuse their models by creating the libraries. So this is all about the define the Simulink model behavior. Next is Simulink simulate and verify the model result. So basically in simulate and verify the model result, once the Simulink model design is complete, the model is simulated to analyze the model's behavior with respect to the requirement with simulation and debugging option. The expected behavior difference are quickly identified, and the model design is adjusted until all the failures are estimated. The simulation is performed in desktop environment. Generate production code automatically. That's the next step, how we can generate the production code automatically. From the Simulink model block diagram, the production level code is generated automatically. After the host hardware setting have been considered, for example, fixed point properties are set for fixed point system. The code can be generated to develop on microcontroller like PLC, FPGA, ASCII, and so on. Autocode generation reduces errors due to manual code writing. The behavior result of generated software code simulations are the compared with the model simulation results, and the model design and parameters are adjusted accordingly to get adjusted performance. So next step is verification and validation. This is all about the V&V process of MBD. Okay, so model based design with Simulink offers early and continuously verification the component. Here you can see in this diagram it's early and continuously verifications. Okay, for each design stage the test cases are prepared and auto generated, and verification is parallel with development stage. Saving test time, each module can be verified independently as a unit and later while integration and then when the target hardware. Different Matlab toolbox are available to validate the design and system against their design results. So that's all about the MBD process steps.